Hello students, welcome to your science class. As you know, recently we are learning chapter 13 Fun with Magnets of your NCERT science textbook. As the name of the title of this chapter, Fun with Magnets, we are learning various interesting fun facts about magnets and about the materials of earth which can be influenced by each other physically, like magnets attracting other objects like iron and some metals. Before we begin today's class, let us have a small briefing of the topics we learned in this chapter till now. We have learned and understood the definition of magnets, the purposes that the magnets serve, an interesting story about the discovery of magnets, and about the naturally occurring and man-made or artificial magnets, different shapes of magnets, and also about the magnetic and non-magnetic materials by understanding an activity. So what are the magnetic materials? If a magnet is capable of attracting materials towards it, then those materials are magnetic materials. Example, iron, nickel, cobalt, steel, brass, etc. What are non-magnetic materials? If a magnet is not capable of attracting few materials towards it, then those are non-magnetic materials. For example, plastic, wood, rubber, etc. In the previous class, we had a question that whether soil is a magnetic material or a non-magnetic material. Let's get answer to this question. Let us learn few more facts about magnets by understanding another activity. To know whether soil is a magnetic material or a non-magnetic material, take a magnet, rub it in the sand or soil, then pull out the magnet. Will there be some particles of sand or soil that will stick to the magnet? If yes, then why? Now, slowly remove the magnet from the sand or soil and gently shake the magnet to loosen the particles which are actually not sticking to the magnet. These are of sand and soil particles actually, which do not stick to the soil. But there will be some particles that will be still sticking to it. What are these? These are small pieces of iron, commonly known as iron filings, which are already present with soil in the soil mixture. And then they get attracted to the magnet when the magnet is picked up from the soil. We are learning this activity because through such an activity, it will be convenient to find where the soil and sand have particles of iron present within them geographically. Try the activity we have just learned near your home or around your home or the places you visit on your holidays. But students, if we try to attract the iron filings in the soil using a magnet, does the magnet look like any of those shown here in the images? Find out by trying this activity. And also note down your readings in your notebook in a table shown here, where you have to write the name of the locations you have tried testing, and opposite to it in the other column you will be writing down your observations of the magnet with iron filings that are stuck to it, are many or are very few, or none of them have been attracted by the magnet. This will let you know whether the soil mixture is rich with iron particles or not at the area where you have tested. Now we are going to learn about the poles of a magnet. Like we already discussed, a magnet has two poles. One end is the north pole of the magnet and the other end is the south pole of the magnet. Let us learn why are they so peculiar. Students, have you ever tried testing a magnet to attract small iron or any small metal objects? If you have tried, have you ever noticed anything special or difference in the way they stick to the magnet? Let us learn that by understanding another activity. Take a plain sheet of paper and spread it on an even surface. Then spread some iron filings on that sheet. Now try to bring a bar magnet onto the paper and place it in the middle. Do all the iron filings get stick to the magnet all over its surface? If you observe the image, can you find more quantity of iron filings getting attracted to only some parts of the bar magnet? They are not completely attracted by the magnet and did not stick to it all over the magnet evenly. Yes? Why? Try to notice the same activity again and again by repeating it for few times. If you try it, no, then notice the same activity again and again by repeating it for few times. Will there be any change in the pattern in which the iron filings get attracted by different parts of the magnet? Observe it if you try it. Like I have already said, if you do not have iron filings to do this activity, you can try to do this activity using metal paper clips or safety pins or iron nails also with different shapes of the magnets, and even with these also you can try to repeat it for a few times to observe any change in the pattern, how they usually get attracted towards the magnet. To understand this observation properly, try this activity and draw a diagram exactly what you have observed to understand the way how the iron particles are getting stuck to the magnet. Compare your diagram to the image shown here and just compare it whether they are similar or not, whether the diagram you have drawn by observing your activity is similar to the image shown here or not. What we actually observe is the iron filings will be attracted more at the regions close to the two ends of the magnet. And these two ends are called the poles of a magnet. Poles of a magnet have the high capacity of either attracting any object or repelling it. But how are these poles located? For that, try to take a simple bar magnet without any markings on it and check for the north and south location of poles on these bar magnets using iron filings. And in the next class, we will continue this chapter. Thank you all.